Good morning, everyone, and welcome to another session of the KETIV Autodesk Virtual Academy. As usual, I'm your host, Nigel Mbayak, and today I'm joined by Thomas Fitzgerald, Senior Implementation Consultant at Autodesk. Good morning, Thomas.
Good morning, guys.
You might recognize that name or that voice, perhaps, if you were here for part one of this Design Automation with iLogic series. It was, I think, exactly a month ago. We might have done this exactly 4 weeks ago with Thomas, where he kind of had an overview of some advanced iLogic capabilities and what exactly it can do for you in regards to getting, some of your processes automated and kind of reducing clicks and amount of time worked on things. So today we're going to be doing part two of that, where we're going to be having a total, I believe, of 5 of these sessions, and each of the ones individually from here on out are going to be kind of based on one section of that workflow. And today it's going to be iLogic techniques for your modeling development, kind of getting your models ready for use of some of the tools available to you. In addition to this, you will be hearing a lot from Thomas. He's going to be doing all 5 of the sessions for us. But in addition to those 5 sessions, he's actually going to be here in the Brea office next month. So what I'm going to go ahead and do right now is I'm going to post a link into the chat, which goes to a design workshop that we're going to be hosting here in the Brea office next month. And that is actually the end of this month, actually a couple of weeks, March 29th. I thought it was the beginning of next month for some reason. And so, Thomas, if you want to explain what that's going to be.
Yeah, sure. So, yeah, March 29th, I'm going to be at the Brea office in California, and we're going to be extending and expanding on some of the things that we're talking about within this series of webinars. However, this series of webinars is very focused on automation, design automation, and we're using the context of an example to follow through that. However, on March 29th, when I am there in Brea, we're going to be discussing a lot more things in terms of how can we use iLogic at many different levels. At the part level, at the assembly level, even at the drawing level. We'll also be discussing some extended functionality utilizing the Inventor API. And we're going to even be touching a little bit on the VBA editor inside of Inventor 2 and how that can help. So a multitude of points, conversation points, hopefully to arise some interest and some potential work in the future in terms of how can we help you guys, and what can you take back with you and then start putting together immediately in your own businesses using iLogic, not just even for design automation, but just in general through any type of context that you're looking for.
Exactly. So I left the link there in the chat box, so all of you who are in the audience can see that. If you want to read up a little bit more on the format, how that's going to be done, definitely click there. There's going to be 2 sessions, a morning and an afternoon session, both having the same content pretty much, just kind of to accommodate for people's schedules. So with that, I'll let you take over, Thomas.
All right, thank you. So as we stated earlier, this is part 2. Last time we had an introductory webinar about iLogic, and to kind of frame the context of the design automation project in which I was demonstrating and the key aspects of design automation using iLogic. So thank you everybody for joining us for part 2, for the second one here. As stated before, my name is Tom Fitzgerald. I am a Senior Implementation Consultant at Autodesk. I've been with Autodesk for about 6 years now. Prior to that, I was as an independent contractor for a number of years, as well as a consultant with a reseller, just like my friends at KETIV here. So I was doing that for a number of years, about 3-4 years prior to that. So I've been consulting with Inventor and data management for about 10 years now. iLogic came out in 2008, so nearly 10 years working specifically with iLogic as well. So I've had the pleasure of working with both large and small companies, implementing iLogic techniques and concepts in order to make their engineering processes more robust, more consistent, less errors, those types of things all kind of work their way back to low overhead and cost savings and profitability for the company. So these are all good things that you want to incorporate into your design processes, if at all possible. Today, we are going to be focusing on model development. So the last webinar, we broke it down into the 4 key aspects of design automation and what those 4 things truly are. Model development, this is where we use Inventor, the editing tools within Inventor, to create our models and then store them, obviously. The data source, which we'll be talking about next time, has to do with Excel spreadsheets, SQL databases, Access databases, and XML files, other formats in which we can collect common information or critical design information as necessary and store that so that way we can reuse and revisit that information as necessary. The third aspect is the logic and the rules. What do we need to do? What can we incorporate in terms of what we understand about our products? What do we make in our company? How do those things work together? How do they get constrained? If this, then that. What are all the different conditions in the logic revolving around what we're trying to accomplish? And then lastly is the user interface. How do we present this? If necessary, how do we present this to an end user, be it an engineer, a sales individual, whatever the case might be? How do we give them a means to input the relative or valuable information as necessary? Okay, so this webcast obviously will demonstrate what we're going to be doing in terms of the design automation focus, and we'll be working on the techniques working specifically within the Inventor models. Now that can be part models and or assembly models. Most of today we're going to be working within the part modeling environment, touch a little bit on assembly models, but for the context of our project here, it's mostly going to be part file environment, so part environment. Okay, so this is a workflow that I presented the last time, and this kind of gives us an idea of what we're working with for our configurator and how the flow of information works through developing iLogic configurators. Today, we're going to work on the Inventor library aspect of it. So as we develop configurators, we need all 4 of these components to some degree in order to be successful and understand how to work or flow the information through the process to get the desired result. And typically the desired result is one of 2 things, if not both of them, and that is some sort of accurate drawing to define how we want to manufacture or produce what it is that we manufacture or produce. So detailed information, views, geometry, dimensions, text, bill of material, those types of things. And the second thing is the accuracy and consistency of our models themselves, because as we all know, there's that association between the models and the drawings. So without having accurate models, there's a good chance you won't have accurate drawings. So if the takeaway, if the critical deliverable file is either a drawing or a model, this is where we need to focus on initially. Start from the bottom, work our way up, make sure from the initial point of development with our models that we have a good foundation. Okay, so what defines a good foundation? How do we create a good foundation within our models? Well, one of the first questions that we need to ask ourselves when going through the process of developing design automation is, are the models in which we're going to be working with static or are they going to be dynamic? Okay, static files, they never change. They're always the same. They're very easy to maintain. Once you develop them, they don't change. Typically we associate a stock number or a part number to them, and then they go and they sit in this directory and we just consume them. We just use them as necessary. Think of it in a physical manner of if you want to assemble something, whatever it is that you produce, and you had a big table in front of you, you would go and grab and get all the different pieces that you needed to put together and bring it out onto this table, and then once it's there, then you put it together. You're not changing those files. You're not manipulating those files. They're static. Okay, so this is by and large the easiest way of working with design automation. You develop the models, you put them out there, and then we just consume them as necessary. Dynamic files obviously are a little bit more, they're more complex. They could potentially change. We have to give them special attention. Now, how do we understand that? Do they change? Do they change based upon geometry? Is it metadata that changes? Meaning, is it just property information that changes, but the geometry stays the same? Either way, we have to ensure that we're accommodating the fact that they're different. And most everybody's policy or processes within engineering is if it's different, it requires a new file name, a new stock number, or a new part number, or some sort of an internal number to identify and differentiate our different files and their particular configurations. So are they static or are they dynamic? Depending on this question will determine the next steps in which you take for your design automation. If they're static files, typically all we have to do is then develop some level of code to bring a file in. So we need to understand what the file name is, and we need to understand where it's located at. So file name and file path are mostly the biggest things that we need to be concerned about. When we talk about file names, how about a file name convention? A lot of companies have some sort of smart file naming convention where they either preface or suffix different information to identify a category of files in which they belong to. Is it a steel shape? Is it a fastener? Is it a pump? Is it something else? So they will put intelligent information for their file names. Other companies don't. There is no direct correlation between file names and part numbers, where it's just a sequential or a random number that they use to identify the difference between files. And there's no way that you can look at those file names and understand what kind of file it is. Obviously, if you're working with that kind of scheme, you certainly have to take special care of your files and in determining how you're going to be able to identify and then, of course, consume those files as necessary. And now that I'm just speaking of that out loud, this is where potentially having a data source becomes very critical, because then you can list all those different file names and then have other information relative to those file names that you can search by, as opposed to a sequential random number. So we'll get into that in future webinars, but understand for static files, file name and file path are by and large the most important thing to be concerned about. Dynamic files, well, how do we ensure that we are starting correctly? How do we ensure that our foundation for our dynamic files is where we want it to be? This is where we focus on templates. If you're not using templates to the full capacity in which you can, you really need to be understanding what you can and cannot do with templates. Templates can be anything. You can have blank files as a template, or you can have fully modified and included files. When I say include, I mean you can have geometry already in those files. You can have parameters and properties already created and some sort of value applied to them at the template level as well. And this gives you a really good starting point to further your design using those templates. File naming convention, just touched on that a little bit. Is it sequential? Is it smart file naming? Understanding what you're doing in terms of file naming and what you can be doing, having that knowledge can go a long way. Directory structure. This kind of goes back to file name and path with static files, but with dynamic files, because you could potentially be creating files on the fly. Sometimes you will have just a big bucket, just a single file with all of your parts and all of your assemblies and everything else in there, your drawings, and it doesn't matter simply because there's no human, there's no person that has to apply some level of intelligence to be able to find these files. And that's typically why we create a folder structure. We name a folder parts, and then under that we say, steel parts or plastic parts. So we give it categorization based upon file directory and or folder structure rather. So understanding what directory structure you want to use. Is there a better one or a not a good directory structure to use? Not really. Simply because as long as you know where it's at and you can syntax that path, then really there's no right or wrong way of doing a directory structure. Just understanding what should you do in terms of what have you been doing. And like I've said this for many years, just because you're doing something or you have been doing something for many years doesn't necessarily mean it's the right way of doing it. So always investigate your processes in terms of templates, file naming convention, and directory structure. And then lastly, with dynamic files, what level of detail do you want to incorporate with your models? I have seen companies that have added every single fillet and chamfer and hole and every last detail to their models to the point where they're so large, and their machines, their physical machine doesn't have the resources in order to work with those models very effectively or efficiently. So what level of detail is absolutely positively required based upon what you're trying to do with your automation? Can you get away with just lesser detailed, smaller files that they truly represent what you're trying to convey? However, it doesn't have the full detail for using or necessary for what we're trying to accomplish with the design automation. I've also worked with companies that had two sets of files, a low level of detail and a high level of detail depending on what they were trying to accomplish. They would use the low level of detail files for their design automation, and then they would use their high level of detail files for specific instances or situations where that was absolutely required. So understanding level of detail will be very important as well. Okay, so this covers the broad stroke of what we should be paying attention to in terms of files. Okay, so let's go into our live demonstration here. I'm going to pull up Inventor, and we're going to talk about a couple of things. So with the static files, let's start off with static files. Like I said before, there's not a whole lot that we need to be concerned about. Mostly it's just file name, file directory, where's the file located at, and then most of all, it's good modeling practice. That's what we need to instill here. Either way, we need to focus on good modeling practice for design automation. And what does that mean? Well, good design automation, let me pull up this guy right here, is things like some of the basics that iLogic needs to understand in terms of file creation. Static files, obviously, you want to build your extrusions and your revolutions first. Give them logical names. If you're not aware of this, guys, at any time, if you slow double click on a feature or something within a model, you can change the name. You can't have any spaces. Well, you shouldn't have any spaces. It's best if you try to either use camel case, which is nothing more than capitalizing each word. So change the name. I capitalize CT and N here. And that is what we use as a differentiator or a delimiter between the words. I've seen other users use underscores. I'm not a big fan of underscores, and there's a reason why. It's because you're adding unnecessary characters. Camel case works perfectly fine. I've used it for years. I've never had any issues with camel case, and I thoroughly and fully endorse the usage of camel case. Meaning, don't use underscores, guys. There's really no purpose. You're just adding extra characters that you have to maintain later on. Okay, so you can change the names of files in the browser. You can also change the names of features in at the file level. So if I break down here into this component right here, let's go into this pulley end. This pulley end is used in extrusion number 2. Go ahead and change those. Give those features logical names, because once we get into things like when we get into the iLogic rules and we start manipulating things, those features are going to be represented here in the rule editor. So we're going to be able to see, oh, this is the main extrusion, or this is, you know, a fillet that controls the boundary of something, you know. So you can give logical names to be able to differentiate what your features are, because as you start perusing and drilling down into these features, you're going to want to be able to access specific information. If you have a huge model that has, you know, 14 different extrusions in them and they're named 1 through 14, it's very hard to understand what it is that you want to manipulate, okay? Potentially manipulate later on. Okay, so static files, just good design practice. You know, try not to use too many patterns, feature patterns. Those have a tendency to bloat a file, unless of course you're using some level of efficiency with it. Save your fillets and chamfers for last if at all possible. Try to do the bulk of your model building towards the beginning, and then refine or start adding that level of detail as you progress through the model development. Okay. With
so
dynamic,
one thing,
yes.
Real quick, Tom. We got a question here. Can you just reiterate the term camel case, and then just like how that's spelled? That's like the animal camel, and then case, C-A-S-E.
C-A-M-E-L, C-A-S-E. Yep, camel case. You can do a Google search on it. It's very rudimentary coding process. Yeah.
Yep. Just want to cover that before we move on. So go ahead.
Yeah, and you'll see early coders, or I shouldn't even say coders, individuals that use Inventor early on, you'll see a lot of examples out there on the internet. Even some of the early ones that I've done, I used underscore, and it was through the process of working with other companies and really digging into these projects that it became apparent that camel case is far and away a better way of defining and labeling different things. And you'll see that throughout my demonstrations here. It's not just for features. I use it throughout all the coding, the iLogic rules and everything else as well. So, okay. So with that, a static, let's go into dynamic files a little bit, okay? So dynamic files, they're, like I said, they're a lot more to be attentive about. You have to pay attention to how we're working with dynamic files, because they can always be changing, and because of that potentiality for change, we need to be aware of how we're manipulating them. Okay, with files, with both part files and assembly files, we are all aware of working with parameters. This is the key aspect, the very valuable aspect to design automation, because we use parameters as placeholders. We use parameters as triggers. We associate parameters to dimensions, so they're extremely valuable for storing and using information at the file level. And a month ago, when I gave the first webinar, I had discussed about data sources, where I said Excel spreadsheets can be data sources and Access databases can be data sources. Well, files, Inventor files, can be data sources as well, because they store information. They have placeholders. You can put information in and reuse or access that information as necessary. So parameters, a couple things about parameters. Model parameters I don't typically mess around with. I kind of let the system take care of the model parameters at will. It's the user parameters that I focus on, and I say this simply because as opposed to going in here and renaming D5, maybe D5 is end face diameter. I could rename that end face diameter, but I don't want to do that with model parameters, because model parameters are always associated to a dimension. Okay, they're created when a dimension is needed for geometry. If you delete the geometry, the model parameter goes away. So if you create a model parameter for a dimension and you reuse that model parameter for a different feature or in a different part of the model, you can create confusion and frustration of how we want to reuse this information. I always create user parameters simply because I have more control over when they're being created, what name they have, obviously, and if I start changing the geometry, the user parameters won't go away. They're always going to be there. So I have more capability in the sense of editing and manipulating files if I define user parameters as opposed to model parameters. Not only that, model parameters, because they're being created by the system, they're going to inherit their unit type based upon the activity in which you're doing. Whereas user parameters, if I want it to be numeric or textual or a Boolean, I define that at the time of creation when I create the user parameter. So a lot more capability, a lot more flexibility. Fully encourage you to create user parameters that you want to name and then associate those within your geometry as necessary. And what I mean by that is if I go down into my sketch here, you'll see that these parameters or these dimensions are associated to these user parameters. So if I change the user parameters, it will change the model parameter and then change the dimension, ultimately changing the geometry. So if you're not familiar with user parameters, I highly suggest you start using them because they are critical with design automation. Okay. Other things with parameters, I don't think I'm going to go too deep into this. Just to understand the parameter editor, key parameters will become handy later on. If you create user parameters and they're extremely valuable to you for use with firing off different rules, always key them up because you can use this nice little filter down here. Say, I only want to see the key parameter. So if I have 150 parameters in here, but only 4 of them are of any importance, I key those, I filter it, and now those are the only parameters that I'm seeing. Okay, so good to key your important parameters so that way you have, once again, you have more flexibility with your models. Okay. So naming of parameters, keying parameters. Next thing is properties. We've all worked with properties before. If I right-click and I go to the iProperties, I have a number of different tabs here. This is by default placeholders for information about my files. Okay. The project tab is the one that's probably most used, project and custom. The project tab where we can define the part number, the stock number, other aspects. We can use iLogic to add information to these. The custom tab is also very important because, as we all know, each company is slightly different. There's going to be different properties that are going to be valuable to you, but not to company down the street. You know, they have different processes. They create a different or manufacture a different product. So highly encourage creating and using custom properties that are very specific that the standard properties don't deal with. Okay. So when it comes to properties and parameters, just getting into the at a file level here, getting into the iLogic editor, you'll see a couple things. Actually, let me go to this guy right here. And what I'm going to do is I'm going to create a simple rule here, just to kind of show you a couple things here. If I wanted to manipulate a parameter, I can see my user parameters in my browser here, and if I double click on any one of them, they're going to be pasted down into my rule editor. And you'll notice that it's blue right now, and that is because Inventor understands that this is a recognized parameter. And what it's doing is it's accessing that parameter at the time when I run this line of code. However, there's going to be instances where you may be pushing or pulling values around, and a parameter might get its value from some other process, and it may not be updated. It may be in memory, but it may not have updated the actual parameter at the time when we fire. And that's when sometimes you'll see or you'll use this document update. You'll use that document update snippet, or one of the other ones. If you're working with an assembly, you're going to do you're going to run where is it? Update when done. So you'll run through the entire process, and then at the very end of the entire process, you want to update everything. So you'll use these updates in order to ensure that any values that are sitting in memory are actually getting updated within the placeholders, the parameters themselves. You'll also see sometimes rules parameter output, and that does the same thing. Is it at this line of code, I'm taking all the parameters that might be sitting in memory and making sure they're outputted to the placeholders in which they need to be. And then we do an update, and now it's almost like refreshing the system. It's almost like saying, okay, I've run this code, I've created some values for these codes, and now I want to make sure that all the placeholders, all the parameters, properties, and everything else have the accurate values before I move on, because I need to ensure I have those accurate values for other lines of code in the future. Okay, so rule parameter output, updating. Another way that you can get about without having to use those, and I use this very commonly, is I specifically call out the parameter function here, where I'll say now by putting it in this format, I'm accessing that parameter and making sure it's updated at the time in which I need it. Okay, so two things going on here, two things that are very important. One is if I have my parameter, if I have it recognized within my model and where it's blue. Okay, so here it is a recognized parameter, it's blue. Anytime that you have recognized parameters inside of a rule and that parameter changes, by default, it's going to run that rule. Now that may or may not be what you want. There may be times when you want to manipulate a whole slew of parameters, and then once they're changed, then run the code. Okay, so if that's the case, if you want to manipulate a bunch of parameters, then run the code, then you certainly do not want to have it like this. You don't want it to be a recognized parameter inside of the rule, because iLogic will say, this is a recognized parameter, you've changed it, now I'm going to run this rule. And you may not want to at that particular time, in which case you'll use this format instead. This is still a parameter, we're still accessing the parameter, but iLogic doesn't want to fire the rule by default by having this in. So they do the exact same thing, you know, they're still accessing the parameter, however, one is recognized, one is, we're just making a call to it, and it's not monitoring this parameter. So that's a key thing to understand, and you'll see that as we progress with the webinars, where I'll use this on occasion, the recognized parameter, but the vast majority of the time I'm specifically calling parameters when I need them, and once again I have far more control of what is happening with my rules, and I'm understanding line by line what is occurring, so that way I have control over the system. The system isn't controlling me. Okay. Same thing with properties. Whenever we want to work with properties, like this is a common one, part number. This is, I'm accessing the property value on the project tab, and I'm accessing the part number property. Okay, so how do we push and pull information? This is the snippet in which we would use for that. If you have a custom snippet is here, but it's the same thing. I mean, it's just syntax. So it's basically all it's doing is just changing out what tab we're going to be on. So it's delineated by the tab, and then of course you have to put in the property name that you want because it's custom. Okay. Parameters, properties, features. Okay. When it comes to features, there's another aspect to working with parameters and features that some of you may or may not be familiar with. And as with my iLogic code, I can call on different parameters to be of a particular value based upon, in this situation, if these values meet this criteria, then this parameter is going to be that value. Okay. We can also control, let me go back into the face thickness. I can also control things like feature visibility or feature activity or suppression rather. So in this case, using this snippet, I can say feature is active. What feature name do I want to access? It's going to be extrusion number 2. Go to my names, just double click there, and I paste extrusion number 2 in there. equals true, because I'm controlling the suppression state. So in code, I can say if a condition exists, now this feature is on, else the feature is off, okay? So I could do an if-then statement there if I wanted to, or what I could do, if I cancel this, I'm going to say no, or what I can do is I could create a parameter. Let me create a numerical parameter. I'm going to call this trigger, I'm going to call this feature trigger. And my feature trigger, I'm going to make this a unitless value. And this is a very powerful parameter type or unit type. And we're going to go into this more as we progress through these webinars. But unitless is very valuable because we use it with patterns, and we can also use it as just a numerical value, just an integer value. So my feature trigger is set to 1 right now. So 1 would be on, 0 would be off. Okay, so I'm going to make this a multi-value list, and I'm going to make 0 my other option. Okay, so now I have 2 options here, 0 or 1. Okay, 0 or 1. And what I can do is, now that I have that parameter in place, I can do something like this. In my properties for my feature, I can say suppress if that trigger equals 0. Okay, so now that I have that set, if it's a 0, then it's going to be off, and if it's a 1, it's going to be on. So I can do 0, and now it's off, and I can do 1, and now it's on. So I don't necessarily have to use iLogic code in order to control feature visibility. I can just use the inherent capability within Inventor to do the same thing. Okay, and then now, instead of writing a line of code to turn that feature on and off, feature is active, I just need to set a parameter value, and then it's going to do the same thing. So just a little tip and trick there of working kind of with iLogic, but still leveraging the basic functionality of Inventor as well. Okay, that's a good little tip. Same thing with features or feature patterns. Let me see here. Do I have a feature pattern available? I do. No, I don't, actually. Don't have a feature pattern. Feature patterns work the same way. When we want to create a pattern, let me drill down into here. If we wanted to create a pattern of something, this is not a good example. What I could do is, if I want to pattern anything, I'm going to need 2 bits of information. Is number 1, what feature, and then what. Actually, I need 2 bits of information. I need to know how many instances I want, how many instances are required for this pattern, and then some sort of value in terms of spacing or distance or length. Okay, so a value for distance, and then a numerical value for count. And count, you always use count with a unitless value. Anytime you want to create a parameter to say, I want to create a feature pattern, and I always give it a number at the end. And the reason why I do that is because no matter what, regardless of the situation, every time I go into and work with a model, and I think I only need 1 feature pattern, I always come up with 2 or 3 or 4 somehow, some way. So I always throw a number at the end. That way, in case I ever need to loop through them, and we'll go into that later on in future webinars about looping, then I can differentiate that far easier. So feature pattern 1, give it a unitless value once again, and then now you're not worried with all you have to do is set that value, and that's how many instances you're going to get for that feature pattern. Okay. So now we have some basic understanding as to how to manipulate parameters, properties, features at the part level. One of the things that is important, if we go back here to our PowerPoint, if we go back here and we look at our workflow here. So in terms of this configure, the design automation, we're working with either static or dynamic parts within our library. As stated before, if they're static, we're just going to do a component replace. We're just going to bring in what we need and take out what we don't need, and that's fairly simple. However, what if they're dynamic? What if we need to do a component replace, but these files are dynamic? This presents a problem that typically we need to address. And what I mean by that is, if I have, let's use this head pulley as an example. Okay, so right now this head pulley is in an assembly, so it's a sub-assembly. And right now it is using the reference, it's using the head pulley 36 assembly, okay? And that's because this particular head pulley happens to be 36 inches in size, and it's also pulling the file reference is also in this location right here, okay? So if I pull up that location, that is right here, and I go into head pulley sizes, you're going to notice that there's just the one assembly, head pulley 36, in that file directory. Okay. So if I want to make a new one, this is going to be a dynamic head pulley. I want to create a different size one. Well, in order for me to do that, I need to think about this more thoroughly. What if I had, I want to change this to maybe a 42 inch. I want to change this to a 42 inch head pulley. If I go ahead and change that to 42 inches, my code, the way I have it set up right now, is going to do a couple things, okay? It's going to do a couple things. As you notice, I just changed that to 42, and now what it's doing is it has a reference now to head pulley 42 assembly. So that is an entirely different assembly right now that I created using the code. So what I did is, how do I do that, and why do I need to do that? Well, if you have multiple users creating these configurations, and user A needs head pulley 42, and user B just created head pulley 42, it's already out there. It's already in the directory. I don't need to go through the process of recreating it. I'll just reuse the one that's already there. However, if it's not created, I want iLogic and Inventor to create it, so that way it's readily available. Now I'm not recreating the wheel every time. I'm only using the information in which I need that hasn't been created. I'm only creating new information. So what are we doing here? I'm setting the path for where the files are located at. I've created some sort of naming convention. I've used head pulley plus the head pulley size, which I'm defining up here on the first line, and it's pulling its value from the head pulley parameter. So whatever value I put into this parameter, it's going to feed this variable. This variable, HP size, is used in the string syntax here for deriving what the variable name is, and then I'm using the path and the name to create another variable called path name. Once I've gone through that entire process of defining the variables in which I need, then I'm using what a try function here. So I'm asking Inventor to go out there and look in this directory to see if this file exists. Does this file exist in this directory of that name? If it does, then I'm just going to use a component replace snippet to bring that file in. Okay, so I'm going to bring that file in. That's only if it already exists. If it doesn't exist, now this is where I'm adding my functionality to make my files dynamic. I'm pushing a parameter down to a lower level component. Then once it does that, I have a series of rules in that lower level component that are going to fire to update the model based upon this trigger. Once I do that, then I'm going to run a rule in that lower level component called save copy as. And I'm going to show you that in a minute. Once it saves that copy out to the directory of the new size, the new shape, then it's going to component replace the new component. So now I'm not recreating the wheel. I'm not having to recreate something over and over again. Specifically because it's the design automation that's creating the component to begin with. okay? So what if I need a different size? Maybe I need a 30-inch instead. So that's going to be drastically different. You'll notice the model changed. If I go into my head pulley component right here and go to the iProperties, head pulley 30 was just created. It's in this directory. I can go back over here into my into my folder directory that I incidentally closed, and there's head pulley 30 right there. Just created it a minute ago. Okay. So the save copy as rule. I have a rule here to fire a rule in a subcomponent. If I go down into that subcomponent, I have a save copy as rule here. You'll notice that it's suppressed because I don't want it to automatically run. I only want it to run when I tell it to, and that's from this rule. Only when this rule runs will I run that rule in the lower level component, and that's why I have it suppressed. So it just doesn't randomly run. It only runs when I tell it to. And this is what it looks like. All I'm doing is the same thing as I did previously. I'm defining the file name and the file path, and then I'm just saying, and it's right in the snippets. It's under Document, File Save As, where I can either save it as and don't open it, or save it as and do open it. I'm saving it, and I'm not opening it, and then I'm using the rule at the upper level assembly to then do the component replace after it's been created. Okay, so this is how we deal with checking to see if a file exists in a particular directory. If it does, use it. If it doesn't, create it and then use it. Okay, so that's a very common process or procedure, if you will, in order to handle not having to recreate the wheel. And you can do this at any level. You can do this at upper level assembly. Even, you know, I've worked with this same function here, you know, 3, 4, 5 levels deep within an assembly. It all works the same. You just have to be aware of where are you pushing the information and what are you expecting as a result. Okay. So I guess that pretty much consumes the time that I wanted to take today to kind of give you an understanding of, for models, when working with our models, in the grand scheme of our workflow here, these are the key things that we need to worry about. You know, we need to worry about file name, file path, utilizing templates to build good models, having a very solid file naming convention, something that's consistent and makes sense, and then of course level of detail, and that mostly has to do with performance and efficiency with working with your models and your design automation. So Nigel, that's all I have for right now.
Perfect, perfect. We got a couple of questions. Again, thank you, Tom, for that. Still like a ton of people in here. So if you have any questions, definitely go ahead and type them in to the chat box. I already have a short queue to go through, and I guess we'll start jumping through these real quick. And so Jeffrey, he asked a question kind of at the near the beginning in regards to using spaces in browser names. He's currently using spaces in his browser names and is running into no issues. Should he expect to see any in the future, or is it just like a preference?
Nope. And I'll show you where the problem lies with spaces in names. Okay. And it's not a performance thing by any means. Okay. It simply comes down to efficiency when working with iLogic code. Okay. So in this guy right here, in this, let me go break down in here, this pulley face right here, I can add a space in there, okay? No problem. Inventor doesn't care. It's just a label, okay? However, if I wanted to do something in a rule, so I'm going to add a rule here, and now that I have pulley face here, say I want to manipulate that feature, okay? So I'm going to go into feature, I'm going to say is active, and I'm going to click on my name here, and it's going to be pasted over here. If I double click, it's going to paste that name in there. Okay. If I wanted to, let me do a copy here. I'm going to do the same thing. So if I wanted to change that name, or if I wanted to reuse that, and now I wanted this name to be something else. Okay, if I double click, if I click in my Inventor editor here, it places the cursor where I click. If I double click, it highlights the entire word. Okay, so if I wanted to change this pulley face and I had spaces in there, I can't just double click because now I'm only deleting one of the two words. Without spaces, if I double click, I'm capturing everything within the quotes, and I can easily paste something else in or type something else in. And this is where underscores came in. That's why initially it was important to have underscores, because you're filling that blank space with a character. So you can easily work within the iLogic editor. That's where the enhancement comes from. It's not a performance thing. It doesn't slow you down in terms of what Inventor expects. It's just a better way of working within the editor. Okay?
Definitely, definitely. And along the same lines here for some of these parameter names, if this question came into, if I change the name of a user parameter, will whatever it's referencing to update? So things like the rules, will they update to that new parameter name, and other references to that as well?
They will in certain situations. Okay? So in this case, if I had a parameter, go down here. So I say parameter, and I say it like this, where it's going to be user parameter pulley diameter. Okay. So if I do that, and I call it out like that, and I say equals 10, and let me make sure this is suppressed so I'm not running anything. That's fine, right? If I go and I change pulley diameter in my parameter dialog box, it's not going to change it here because it looks at this as being a string value. However, if I do it this way, where I just double click and now it's a recognized parameter, if I go, let me save that, and now if I go into here and say pulley diameter, right? So I'm just going to call this pulley diameter, like that. And now let me go back into my iLogic rule. You'll see that it doesn't change anything. It actually made pulley diameter not blue anymore because it's not recognized, right? And it didn't change it here as well. But if I would use the parameter in features, if I would use that within a feature or in a pattern, yes, it will update there, but not within the rule editor. No. What I have found that works the best for a situation like that, if you want to change, use this up here. Use your copy and replace under search and replace options in your rule editor. Now I can say I want to find everything that says pulley DIA, right? And I want to replace it with pulley diameter. Replace, replace. And now I've updated my rule. Everything should work fine. I'm good to go.
And it's showing up as a blue parameter.
Yes.
So that's hopefully that answers that question for you.
Because now it's recognized because I changed it here first, and now it's recognized here inside of the rule.
Certainly. And we've got a couple more. We'll try to run through these real quickly here. Thanks everyone for staying for so long. I know that sometimes it takes a little bit longer to do something so in-depth or something so complicated as iLogic and automation in general, but it's good to see that the vast majority of you are still here. So let's go ahead and answer a couple more questions. This one comes from Corey. It seems that you prefer save copy as rule as opposed to pack and go. Is there a benefit from that method besides speed?
Well, a pack and go. Pack and go here inside of iLogic really doesn't make a lot of sense. Pack and go is an Inventor functionality that allows you to capture an upper level assembly, or rather a file that has references. That's the best way to break it down. If I have an assembly with 20 parts and multiple sub-assemblies with parts, pack and go is definitely the way you want to, the feature that you want to use, because it will grab everything. It looks at those file references and grabs everything in one shot. iLogic, we're not doing that. We're just doing. Well, you can do a pack and go if you want to create static subassemblies. What I mean by that is if you create a subassembly that has a configuration that you desire, and now you have another subassembly that is similar but slightly different, sure, do a pack and go on that if you want to. If it's, you know, if the file paths are complex and you don't want to track everything down, and or rather you can just do a save of that assembly and it's going to grab it. You can do the same thing with a drawing because it has file references as well. So pack and go is typically the methodology in which you want to use if you want to share information to with somebody else outside of your network, outside of your core company. You know, grab everything that's relative to a design and then give everything to somebody else with a different structure, with a different project file, and they will be able to open up without complication. Working internally, you don't need to worry about that because you have full access to your directories. You have access to all your models. So you don't need to understand where all the references are because you're building the references. That's what the design automation is all about.
Certainly, certainly. There's a really big question here from George in regards to using Visual Basic to manipulate all of this stuff. I think that question is better answered in the next webinar we're doing. Is that correct, Thomas?
Next webinar we're going to be doing is will be surrounding data sources. The following one will be about iLogic rules, syntax, the actual Visual Basic coding, where we talk about conditional coding, if then, else if, loops, try catches, things like that. That's where we're going to be breaking down into the best practices of coding with Visual Basic, yes.
Exactly. So hopefully that answered your question a little bit there, George. It is possible to use Visual Basic to manipulate some of this stuff, and we're going to go over that in a future webcast.
Yes,
along those same lines, the next webcast we'll be doing, we came up with a date. That's going to be April 27th. So April 27th at 10 a.m., same time, same place. Maybe you won't be in the same place, but I'll definitely be here in this room. But yeah, that'll be the next webcast for iLogic, and that's going to be part 3. So don't miss out on that. Last question before we get going here. Looks like we're already around 11 o'clock. If there's a question, there's a couple that I'll answer, or I'll send to Thomas to answer after the fact. These ones are a little bit longer, I think, in terms of the answer. But this one looks like it might be pretty short. This one's another question from Jeff. Is there an effective way to place component occurrences from scratch as opposed to doing a replace component? Is there an easy way for iLogic to be able to do that?
From scratch, yes. As a matter of fact, that was. Am I presenting? Because yeah, I can still present it. All right. One of the things that we do with component replace, or rather, inserting components. So from scratch, yes. In my demonstration here that I did last week, that was one of the things that I briefly talked about, and it's right here. It's this little bit right here, and it uses the Inventor API. And this is what we're doing. We're adding components, add occurrence right here. We're adding components using this little bit of code right here. So to add a component to an assembly inside of iLogic, you need two things. We need to know the name, or we need two things. We need to know the name and where you want to put it relative in 3D space inside of the assembly. Okay? So that's what's happening on this line right here. So I'm calling the add command. I'm adding a component from this directory using this part number, and I'm setting it using this variable. I'm setting it at 000 in this case. Okay, so it's a simple API function where we just say I'm going to add a file. This is its name. This is where it's located at, and this is where I'm going to place it in 3D space. And then there's other parameters that go along with it, like, do I want it grounded? Yes or no? Do I want it visible? Yes or no? Do I want it enabled? Yes or no? So there's a multitude of parameters that we follow with that as well, and we're going to break down into that more closely or more thoroughly in incoming sessions as well.
Definitely, definitely. So Along the same lines, or I guess similar lines, I think that's the last question we'll cover today. There's a couple more in here. I'll definitely make sure that those get sent to Thomas so that he can take a look at those. Those might be a little bit more in-depth in regards to the answer. Again, I'd like to thank you, Thomas, for being here today and for agreeing to do these this group of sessions. It's definitely a first for us to do a like 5-parter, kind of go super in-depth into a topic, which is super great.
My pleasure, guys. I'm really happy and excited of working with you guys on these, and I hope that those of you that are following along or viewing the videos later on can get some value out of it. And please, if you're in the Brea area, show up on the 29th, and we'll have far more to discuss and hopefully be able to answer a lot of questions as well.
Exactly. So hope to see you all there, and I think that's it for this week. We'll see you all next week when back to our normal webcasting. Same time, same place, KETIV AVA. So with that, I'll see you all next week. Thank you, everybody.